afternoon everyone, welcome to the channel after a long time. In today's video I want to show how we can perform whole slide image processing using a helpful library in Python called OpenSlide. So whole slide images are basically digitized versions of microscopic glass slides that can be processed in a computer. Okay, let's get started. Things will be more clear if I show an example. So as usual, I want to import required libraries at first. So we need OpenSlide. From OpenSlide we need OpenSlide object. Then we need pillow. We have to mention a special line here. So maximum image pixels is none because the whole slide image that I will be working with is very large. If I do not provide this line, then I cannot load the large WSI that I have available. Okay, so these are the required libraries. Now I want to first visualize the whole slide image. So this is the whole slide image. WSI.sbs. .sbs is a typical file format for whole slide images that are usually created using scanners like Apereo, Axio, Scan and some other special scanners. So let's see the size. So we can see the size is 78,522 pixels and 20,094 pixels. Let's just say if I multiply this 94, it becomes a huge number. 1 2 3 4 5 6 10 digits. I think the maximum digits by default for loading an image using pillow is less than that. For that reason we have to mention this line, otherwise we cannot load this image. Okay, remove this and let's visualize. So plt.axis off. It will take little bit of time because this is a large WSI with a huge size. So I am waiting for a few seconds. Okay, finally it's loaded. So this is what this file looks like. These are some kind of tissue of some animal or something, I don't know. Now we want to view some properties of this image using the OpenSlide object. Okay, so this is used to open a WSI using OpenSlide. So to open WSI, now let's check some things. So delete the format of this file. So this line will return the vendor name, company name basically. So it says Apereo. Okay, Apereo is scanner. Now let's check level count. So it shows the number of levels in the WSI. So number of levels means different types of resolutions. Some resolutions are very high, some are slightly lower. Pixel information is how to say allocated at different resolutions in this WSI. So we can see there are 4 levels in this WSI. We can also check the dimensions. So this will return width and height in level 0. So level 0 has the highest resolution. So this is the highest resolution that we also saw here. But if we want to see all the level dimensions, that is also possible. Now this will give the width and height in all levels. So this is level 0, the highest, level 1, second highest, level 2 and level 3. There are 4 levels where pixel information is stored in different how to say different magnifications or something like that. Okay, and notice that this is width and height, because if you look at that image, this side is longer and this is shorter, so width is higher than the height. We can also check slide dot level downsamples, shows downsample factors for each on the slide. So the easiest way to understand this, let's take this value for example. For the second level or level 1, because indexing starts from 0, so 0, 1, 2, 3, the width is saying 19,630 and the factor string 4 point something. Let's just multiply it with 4, we get 78,520, which is quite close to this value. So this is what this downsample factors is basically showing. Now we can also check metadata by accessing the properties. So this line of code shows the metadata in the WSI. Sorry, not slide again, we already used slide props. So we get so many information, too much to look at, but there are definitely some important. For example, this is the magnification, and let's this is the vendor, and what else is important, and this is the number of levels. Okay, we do not need to look at this one, but this is the metadata. Now we can obviously check few important information from it. So let's say slide props. So as I have already shown, let's just copy this part. So this will give the optical magnification, which is obviously 40. And another thing that I have just shown was, I think, vendor. So OpenSlide vendor, let's copy this one. Shows vendor name Apereo. We have also found this name using another way, using this detect format. Okay, let's also see these properties in some other way. So there is an option to check standard properties. Let's say slide props, OpenSlide property name vendor, identification of the vendor. So basically it's same as this one, but different way of accessing. Let's check another. Let's open slide dot property name comment. Okay, let's see what it gives. Okay, so it gives some characteristics like this app 40. So I think these are also accessible from here, so probably not that important. Now let's check another slide props, property name objective power. So this will basically give the magnification of the optical lens. We have already seen in another way, 40 and 40 here as well. OpenSlide dot mppx. So this is the number of microns per pixel in the x dimension of level 0, highest level basically. So 0.2485. You can also see the y dimension. It should be the same for this particular scanner. So we get the same in both x and y dimension. I think these are all. I want to change it. So standard properties. So by using this property we can access the standard properties. Now let's go back to our object. So get a thumbnail of our WSI. So this will be a resized image. So let's call it slide thumb, slide.get let's mention the size as 400 slide thumb. So it's the same image as this one but resized. So this should appear a little more blurry but difficult to understand from here, but you can obviously check the size. It says 400 and 102. Even though we mentioned 400 by 400, it's showing 400 by 100 by 2 because this is not a square slide. Width and height is not the same. It looks like a rectangle. That's why even though we provided 400 by 400, we are getting 400 by 102. Now we have already checked this before. Slide dot level dimensions. So there are 4 dimensions. So this is the highest, then other 3 as well. This is the same as this one. So now let's select a particular level. Level 3. So level 3 is this one. This is 0, 1, 2, 3. So this is basically teams 2 indexing. Now we can level 3 IMG. Now we can read a certain region from this level. So slide dot read region. We have to first provide a location, starting location, then the level, which is 2, then a particular size. So this is basically location, level and size. Insert the bracket, I mean this part, and we can obviously check the size. So as this is the size is 1500 by 1000. Read region object returns an RGBA image. We can obviously check this from mode. See, the mode is RGBA, obtained from this object. Let's visualize this particular portion. So level 3 mg dot axis off. Okay, so this is the top left pixel, 0, 0 is starting from here. We have extracted this till this part, so we are not getting an image of this size. We are only getting a portion. Okay, so this is top left, then this is how 1500 width, this is 1500, this is 1000. Now we can obviously convert RGB image, RGB. So level 3 RGB, IMG convert RGB, PLT dot im show PLT.axis off. So this is the RGB version of the thumbnail, and this is the RGBA version of the thumbnail. Okay, let's check the mode to be clear. So this is RGB and previously it was RGBA. Now return the best level for displaying the given down sample. Let's say down sample is equal to 20. Best level is slide dot get down sample. So for this particular down sample of 20, the base level is 2. So basically this one. Now let's perform tiling from slide. Create a tiles object, deep zoom generator. We have to provide our slide, then mention a tile size, let's say 224, and overlap 0. So there will be no overlap. We are creating tiles object here. Okay, now let's print number of deep zoom levels. This will be tiles dot level count. Print another new line here, and also print tiles dot level dimensions. So this returns a list of tuples each deep zoom level. So there are 18 deep zoom levels, and we can see these 18 deep zoom levels here. Okay, now let's print number of deep zoom tiles dot tile count. So in 18 levels we have 42,250 tiles in total. Let's examine a particular level, which is level 10. Print tile counts at deep zoom level. This will be level num. So the tile counts at deep zoom level 10 is 3, 1. So we can obviously see all the tile levels. So there are 18 here, so 1 2 3 4 5 6 7 8 9. So 0 1 2 3 4 5 6 7 8 9 10. So this is indexing starts from 0. So 11 12 13 14 17. So this is 17. So this is the 10th and 3 1, and so this effectively means there are 3 tiles in this particular level. So there are level tiles, level num. 0 0 means this one, this is 0 and this is 1, and copy and paste. This will be 1. Tiles in level num. So there are 3 tiles in level 10. 3 multiplied by 1 is equal to 3, and the positioning will be like this. So 0 0, then 1 0, then 2 0. So since the number of columns is 3, it will go from 0 to 2, and since number of rows is 1, it will remain at 0. I think by showing a particular position, this will be clear. Coordinates. So 10 is the level. Let's say 0 0, the first one. So 0 0 10, sorry, column and row. So position, and this is the this is the number of tiles, and this is the pixel information. So I think it's better to mention here returns pixels x, pixels y for the specified tile. And let's confirm another. We can also get 1 0, we can also get 2 0, but we cannot get 3 0 because it doesn't exist. We cannot also get 0 1 because rows is 1, it also doesn't exist. So I think it's clear. Tile dims, tiles, so this is level 0 0, tile dims, also this is the dimension of this tile. If I change it to 1 0, this is also I think same, but this is probably lower. Okay, now let's see tile count. large image. So for the large image we need this one. This is level. There are 18 levels, but indexing starts from 0, so this is level 7. So we get the exact value as this one. So this effectively means there are 30 on 590 tiles in level 17. So the total number of tiles is this 42 to 53. Among these 31 of 590 belong in this level and 3 belong in this level. I think that's clear. We can obviously confirm it. So tile dims, tiles. So this will be 17 now level, and we can choose within these two numbers. So let's say at first I choose 70 out of 351 and 50. What about tile dims 1? The size is 224 by 224 for this particular position. Let's see the last position. So last position will be 350 and 89 since the indexing starts from 0. I think it's better to call it tile dims 2. So we see it's much smaller than our desired size. Okay, now let's access a single tile. Tiles dot get tile. Let's say 56, 58 position. This is single tile. So within this position the tile looks like this. We can obviously check the size. So size is 224 by 224. We can also see the, so I am saying this is column, this is rows. We can also see in this way tiles, level tiles. So I am using a different level now, 11 11. So 11 11 is this one because 10 is this one. So let's say columns, rows 6 2. So this one is 11. I hope it makes sense. And we can obviously visualize the total tiles in this particular level. So there will be 12 tiles, 6 multiplied by 2, 12 tiles. Positioning will be 0 0 0 1 on 0 1 on 2 0 2 on 3 0 3 on 4 0 4 on 5 0 5 on, 12 in total. So let's create a list for C in range columns, for R in range rows. equals create tile dot. So we already created a single tile. Now instead of a particular position, now we will use these iterables. So and this will give us a pillow image. As you can see here, this gives a pillow image. We have to create it into a numpy array. Sorry, convert it into a numpy array. Create tile, and we can append it to our list. Sorry, what happened? Oh, sorry, I forgot to mention the level. So you see, we have to mention the level. I forgot to mention it. What is happening? Oh, sorry, more mistake. Really, that's really bad. Okay, finally it's okay. So 6 multiplied by 2. If everything is okay, we will get 12 images. So everything is okay. Now let's just visualize. For I in range len gather print gather I dot shape. We can check the shape of each image. Sorry, p dot I am show. I think it's okay. So this is how the first tile looks like. Size 224 by 224. 3 is obviously for color channels, RGB. Second on 90 224 by 3. Then this one is again 224 by something. This is blank, some tissue here, blank again, some tissue here, finally blank again. So these are this is the smallest one, I think 9107. Others are more or less bigger. So that's all for the video. So this is how we can process this particular whole slide image using this library. Thanks for watching.